Hello, period 8. So I'm not in school today, so I'm just going to go over some stuff that I need you to know before I get back. So we were up to the 8th out of the 10 functions on page 12 in your book, and it's the exponential function e to the x. Now, an exponential function can have any base, but the one that we do for the 10 basic is a base of e. E is a number. It's irrational. It's mostly used in calculus, but it is used in this course. It's about 2.718, and it keeps going. It's irrational. It's used, like I said, in calculus, but you're in pre-calc, so that's why we're using E. All right, so let's graph it first. So to graph it, I'm just going to plot a few points. So for exponents, you can plot negative and positive exponents. So I'm going to start with -2. So if you raise e to the -2 power, that is about 0.14. If you raise e to the -1 power, anything to the -1 is just the reciprocal. So it'll be 1 over 2.7, but that is approximately 0.37. If you raise anything to the 0 power, it's 1. And then I'll just do a couple more points. If I do e to the first, it's about 2.7. 2. And if you raise e to the second, and the e button, by the way, is second and then the division sign on your calculator, and that's about 7.4. So I'm just going to graph these points so you can see the shape of the exponential function. And all exponential functions are this shape. And as you keep going towards the negative on the x-axis, it keeps approaching 0, but it never actually hits 0. So that's going to be an asymptote. The domain of all exponential functions are negative to positive infinity. The range is 0 to infinity. The 0 is not included. There are no zeros because it never hits the x-axis. It does not have symmetry, and that means it's neither odd nor even. It is always increasing over its whole domain, which means it's never increasing. It doesn't have any extrema because it doesn't have any minimums or maximums. It does have a horizontal asymptote of the x-axis, which is y equals 0. It doesn't have a vertical asymptote. And even though there's no minimum, it is bounded below because it never is going to hit the x-axis, but it's going to approach it. So there's an asymptote there, and that actually means it's bounded below. And it is continuous because there's no vertical asymptote or holes. All right, the next ones are sine and cosine. You would have learned these in Algebra 2 last year. And if you remember, we usually do sine from 0 to 2 pi. We use radian measure for the x values. I'm going to label the x as 0, pi over 2, pi, 3 pi over 2, 2 pi. And on the other side, I'm going to go to -2 pi. Of course, this graph keeps going, but this is just to show the general shape. And I'm going to just do this for the cosine graph also. So let me just copy this, paste it here also, so I don't have to write it again. All right, sorry about that. So the title for this is called the sine function, S-I-N-E. Oh, and I didn't draw it, but the sine function starts at 0, and it's basically like a wave. It only goes up and down to negative and positive 1, but I'm going to use 3 boxes to show it so you can see the curve better. So it hits its highest point at pi over 2, then it goes back to 0, then it goes down to -1 at 3 pi over 2 and back to 0. So it looks like a wave like that. And then on the other side, it does the same thing. So at negative pi over 2, it hits the lowest point, then back to 0, then the highest point, then back to 0 on that side. So that's what the sine curve looks like. So the domain, and there's arrows on the end, it keeps going. So the domain is negative to positive infinity. The range is negative to positive 1 inclusive. There are many zeros. In fact, there's an infinite amount. So I'm going to start with a dot, dot, dot. And negative pi over 0, negative pi comma 0 is a 0. So is 0, 0. So is pi 0. And every pi radians, it hits 0 again. It does have symmetry over the origin. So if you turn it upside down, it looks exactly the same, which makes it an odd function. It is increasing. This is very annoying, but again, there's infinite times that it's increasing. Negative pi over 2 to pi over 2, it's increasing. And then it's increasing again from negative 3 pi over 2. Positive 3 pi over 2 to actually 5 pi over 2. Now, I only did the graph to 2 pi, but it would increase until it hit 5 pi over 2. And then it keeps going. It keeps increasing at those intervals. Same with the decreasing. We're going to do a dot, dot, dot. But now it's decreasing starting at negative 3 pi over 2. And then it turns around at, and remember, we're doing at x values. It turns around at negative pi over 2. And then it's also decreasing at pi over... Sorry, it's hard to read my thing. I'm sorry, at pi over 2, and it stops decreasing at 3 pi over 2. All right, there is extrema. There's an absolute and a local max and mins at 1 and negative 1. So we would say local absolute max at 1 and a local and absolute min at negative 1. There is no horizontal or vertical asymptotes. And it's just bounded because it's bounded below and above, and it is continuous. Now the cosine curve looks very similar, but the difference is, if you remember from last year, that the cosine curve, instead of starting at 0, 0, it starts at its highest point, which is, if you start at the origin, it goes to 0, 1, and then it goes down. So it hits pi over 2 at 0, and then at pi it goes down to its lowest point. 3 pi over 2 back to 0, and a 2 pi back up, but connected as a curve. And it does the same thing on the other side. And then it keeps going. So its title is the cosine function. Its domain is negative to positive infinity. Its range, just like sine, is negative 1 to 1. And it has infinite zeros, but this time they're at different points. So it hits the x-axis at negative 3 pi over 2, 0. It also hits the x-axis at negative pi over 2, 0. It also hits the x-axis at positive pi over 2, 0. And at 3 pi over 2, 0, and it keeps doing that. So we're going to put some dots. There's infinite zeros. The symmetry this time is y-axis, which makes it even. It's increasing. Again, these are infinite. At negative pi 0, it starts increasing. And it does that. From negative pi to 0, it increases, and then it increases again from pi. Wait, I did this wrong. Sorry. Oh, no, that's right. Negative pi to 0. Sorry. And then unioned with pi to 2 pi. And then it would keep doing that as you keep going. And then it's decreasing at negative 2 pi to negative pi, unioned with, remember, you're using x values for these, 0 to pi. And then there's more after that. Same extrema as sine. So local and absolute minimum at negative 1, and a local and absolute maximum at 1. No asymptotes, and it is also bounded, both up and above and below, but we call that just bounded, and it is continuous. So you'll need all that in your notes, and then you're going to do page 15, which is asking about all those 10 functions. Okay, you also did page 14 already, so I'll just quickly give you the answers to this. This is absolute value of x. This is y equals e to the x, exponential graph. This is y equals x to the third. This is y equals the square root of x. This is y equals x. This is y equals the natural log of x. This one's sine because it's at 0, 0. And this one's cosine because it's at 0, 1. This is the hyperbola 1 over x. And this, of course, is x squared. So you're going to do page 15. And I'm going to have you guys submit that. I'm also going to show you a little bit more that I want you to catch you up on, and this is on page 16, piecewise functions. So we're going to be graphing these using the 10 basic. So the first part of this piecewise function is just y equals x, which is just a line, but we're only using that when x is less than or equal to 0. So that's going to be on this side. And you can plug in points if you need to do that. And then the absolute value of x is going to be when x is greater than 0. Now there would be an open circle at 0, but there's already a closed circle there, so you can't really put an open circle. So the other half of that graph is going to be right there. So it really ends up just looking like y equals x. For the next one, I am going to plug in points because I think it'll be easier. So we're going to use x squared at values that are less than or equal to 0. So 0, -1, -2. So if you square 0, you get 0. You square -1, 1, -2, 4. And I'll also do -3, 9. And that 0 is included. And that's half a parabola over here, but it would keep going. And then the other side is going to be the square root graph. Now, if we plug in 0 there, you would get 0, but it would be an open circle. But we can't put an open circle when there's already a closed one, so it ends up not mattering that point. Then we're going to plug in numbers greater than 0. So I'll plug in 1, and the square root of that is 1. But then I'm going to plug in perfect squares. So if I plug in 4, the square root of it is 2. I'm not going to plug in 2 because then I'm just going to get a long decimal as my y value. And then I'm going to plug in 9 to get 3. I purposely picked perfect squares so it'd be easy to graph. So that's what that looks like. Now there would be an open circle on 0, 0 because of it not being included, but there's already a closed dot there, and that's why there's not. Okay, the next one, e to the x is a pain to graph, but we're going to plug in a few numbers. So it has to be less than or equal to 0, so I'm going to use numbers like 0, -1, -2, -3. Anything to the 0 is 1, so 0, 1 is on there. E to the negative first, you can use your calculator. It's about 0.37. So at -1, you're just going to go up a little bit. E to the -2 is 0.14, which is really close to the x-axis. And if you do -3, it's even closer to the x-axis because it's approaching 0 that way. And that's 0.05. It's so small you really can't even graph it properly. So I'm just going to go like that and draw an arrow. The other one, x to the third, we're going to use numbers greater than 0, but I am going to plug in 0 because you have to know where the open circle goes. So this is going to be an open circle, but when I plug in 0, I get 0. So I'm going to put an open circle there. Then I'm going to plug in 1 for x, which gives me 1. I'm going to plug in 2 for x, which gives me 8. And then I'm going to stop. So that's going to look like that. Now these we were supposed to say, I didn't read all the directions, whether they're continuous or not. And I didn't say it for the first two, but these two are continuous at x equals 0. There's no break in the graph. So these are both continuous at x equals 0. But this one has a discontinuity that you might remember from a couple of units ago. It's called jump discontinuity at x equals 0 because it jumps up. Okay, we're going to do one more of these and then I'm going to stop bothering you. So for this one, we have to use 1 over x for less than 0. So you really can't plug in 0 because it would be undefined. So that's not going to be on the graph. There's actually going to be an asymptote there. Then we're going to plug in numbers less. So -1 would give you -1. If I plug in -2, I'll get -1/2. If I plug in -3, I'll get -1/3. So this is going to be a hyperbola like that, or part of a hyperbola. It's actually going to approach that, but this is going to be an asymptote. Okay, and then the other side of the graph is going to be ln of x. This is kind of a pain to draw, but you can use a calculator again. So for ln of x, I'll do it down here. We're going to use numbers greater than 0, but we are going to plug in 0 also, but it doesn't work. You can put in your calculator ln of 0. It's going to say error. It's undefined there also, which means there's also an asymptote for that graph. Plug in a number greater like 1, do the ln of 1, and you get 0. 1, 0 is on the graph, and then you're going to do ln of 2, and that gives me 0.69. And then if you do ln of 3, you get 1.09, 1.1 about. Maybe we'll just do one more, ln of 4, to see how this is climbing, and it's climbing very slow. That's 1.4. So it's like that, and then it is approaching that asymptote, but it never hits it. So that's a weird one, and that is called infinite discontinuity because there's an asymptote at x equals 0. Okay, so the only assignment you have to do besides copy all these notes into your book is page 15. And I'm going to put it on Google Classroom for you to post. All right, have a good day.